All right, everyone. Welcome to our last Lunch and Learn series event of the year. The presentation is going to be called What's That Pole? So we'll get into that in a little bit in a second. Just a couple of housekeeping notes. Ask you to save the date, January 14th, 2026. We'll have our next Lunch and Learn. I'll be providing that. We'll be talking about SQL and the select by features of ArcGIS and how those things work back and forth. So if you know something about SQL but not how to leverage that in Arc, we'll talk about that. And if you know something about the Arc features of select by location, select by attribute, we'll talk about how to implement those back in the SQL language, a little bit of interoperability. Just as way of introduction of myself and then our other board member that is here, I'm Matt Doobie. I'm the vice chair of the main GIS user group, and Rosemary Mosier is with us, who is currently the treasurer of the user group. Our gold sustaining members, we have CAI Technology, Esri, the main technical source, and Viewshed. What's going on here? Why is my screen not advancing? Sorry about that. Some sort of hidden action here. Well, it doesn't want to cooperate. So let me do it this way. Our silver sustaining members, the Department of Agriculture, Conservation and Forestry, Maine Department of Transportation, Maine Office of GIS, Maine Public Utilities Commission, the Raymond H. Fogler Library at the University of Maine, the Wheatland Geospatial Lab at the University of Maine. Our bronze sustaining members, the Maine Geo Library, CGIS Solutions, Dirigo Spatial Systems, the Greater Portland Council of Governments, GEI Consultants, St. George Consulting Group, Stantec, Stone Environmental, Wright Pierce, and the Kennebunkport and Wells Water District. And without further ado, I'd like to introduce our speaker for today. Our speaker is Lance Alley. He's an asset management analyst at Lewiston Public Works, and he's going to be talking about a project that he's been working on about presumably utility poles. So I will stop my sharing and I will hand it over to Lance. And before Lance gets going, I will emphasize we use the question and answer feature. So if you have questions, please go ahead and use that. And we will address those at the end of the presentation. So without further ado, I'll hand it over to Lance.
Awesome. Thanks, Matt. Hello, everybody. My name is Lance Alley. I am the asset management analyst for the city of Lewiston, Maine. A little bit about my background. I graduated with a degree in biology about a decade ago. I've worked in forestry for 8 years since, dealing mostly with large-scale forestry operations. I've always kind of been the GIS guy in an office full of foresters. And I've always kind of gravitated towards GIS. It's kind of an amazing tool when you start to leverage it with complex systems. I made the leap to full-time GIS in 2020, working with CMP to conduct their field audits of their infrastructure, and then I moved to a full-time GIS manager position for a smaller municipality after that, working primarily with emergency services. Now for Lewiston, I help maintain specifically their GIS or their utility GIS infrastructure, and then kind of help manage their compliance programs for drinking water, stormwater, and wastewater. A little bit about Lewiston. It's pretty interesting because we do maintain the distribution system of our drinking water, our stormwater, and our sewer systems. In other municipalities, this is not always the case. They aren't typically handled by the Public Works Department themselves. So, in addition to all of those utilities, we also maintain our electrical assets. Well, we try to maintain our electrical assets, and I say try because why we do really excel at maintaining what the city of Lewiston owns and operates are kind of our historical records of the private electrical assets in the city haven't been maintained as well. So that leads me to my actual presentation, which I'm going to start here. Share this. Um, go ahead with that. All right. So, as I said, that leads us into our presentation, which is what is that poll? I'm assuming everybody can see this. All right. Uh,
Yep.
Awesome. So a little bit of background on this project. Here, one second. Sorry, jumping around on me. Um, so I had originally titled this presentation as using Google Street View Metadata API to conduct an internal audit of utility pole conditions. I decided that was a bit of a mouthful. So what is that pole seemed to suffice, make it a little more palatable and user-friendly. Today, I just want to give an overview of what we did to give our electrical field staff some tools they needed to perform an audit of our utility poles. I just plan on doing a broad overview, and then some of the GIS prep you'll need to do to be able to use some of these Python scripts if you are interested. I'm not going to be getting into the specifics of the Python code themselves. That would turn out to be a snooze fest, I'm afraid. But if you do want these codes to play with after the presentation, feel free to email me and I will send them to you. And if you aren't a like Power Python user, if you're not a Python user in general, and you still want to do something similar to what we've done, you can just reach out and I can help you walk through the steps you'll need to run some of these. A little bit of background on this project specifically. So we had two data sets that we were looking to collect some information on. We had our metered lights and then our unmetered lights. For those of you who have no idea what these are, I was right there with you. And it turns out that the name unmetered and metered lights is pretty self-explanatory. Metered light is a street light on a metered circuit that we are charged based on usage. And an unmetered light are not tied back to a meter, and we are charged based on the number of unmetered lights we have, and then the time at which they are used. So, and the time at which they are used is all calculated on the back end. The longer days mean less light used, and that's a smaller charge to us, while shorter days mean more light needed and more energy used. So, metered lights were our particular concern because as they are tied back to a meter, we are being charged pretty consistently on those. We were more concerned about being charged for lights that had been removed, and then CMP was concerned about lights we had added to the system that we weren't being charged for. CMP hadn't really performed an audit on this for a minute, and we had not done a very good job of maintaining these records on our end. And neither of us really wanted to do an inventory on it because CMP owns about 8,000 poles in the city of Lewiston, and they were tracking at us at 2,300 unmetered lights. So that's like a huge effort for field staff that's already pretty, our field staff is pretty much a skeleton crew as is. They're usually re doing repairs. They don't have a lot of time to go out and build a GIS infrastructure. And then our GIS team is pretty strapped between all the utilities that we manage. So it's not really going out and walking the entire city of Lewiston and being able to collect this information is probably something that wasn't going to happen. And if it did happen, it wasn't going to happen very quickly. Um, our GIS was built out, but it wasn't necessarily maintained very well. So behind the text here is actually our asset management system, and we had these utility poles mapped over here to the right there. And then we had pictures associated with these poles themselves built out. Um, but this was based on basically three historic data sets. We were using kind of historical street view to compile all these images together. And then we were using a Sewell um, light inventory that we had done, I think in the 2010s. So those were both the problem with using Street View as it was it was basically a variety of years, anywhere from like 2012 to 2023. And as anybody who does data management knows, a lot can happen to a poll over 10 years. So we didn't really want to rely on that older imagery. And then with the Sewell data set, we didn't really have a good handle on how extensively that was updated as well. It was a great starting point at the time, but if you're not managing the lights on that data set, then it becomes essentially useless. So we had a pretty good foundation. We had all of our poles mapped, but we did not have the mobile collection needed to be able to update these assets. So up top again is our asset management system with our poles built out, but then below is actually those attributes that we were tracking on that same light pole. So while we do have the location of it, these attributes weren't being filled in, so we didn't have much information on our system. There was a lot of energy in the setup of this module, but it wasn't really tracking what the electric guys needed. They had some specific things that they were looking to track that weren't built out in our attributes, which I feel like is why they weren't utilizing it as much. Um, yeah. So we were trying to, I don't know, there's a couple birds, one stone that I was hoping to tackle with this. So then we get a new inventory request from CMP. They want to know where our unmetered lights are, and we want to know where our unmetered lights are, particularly for to reduce our overall energy costs. We know we had to remove some of these from our systems throughout the years, but we hadn't really been tracking that. And then if we had to perform a new inventory, what other things could we capture that would give our electric guys some of the additional attributes that they were looking for? I'll touch on that in a little bit. Um, let's see. Some of the things that they did want to capture were the old arc circuits, like double poles, poles in poor locations. Uh, but our old system wasn't set up to really do that. And our old system was resource heavy, or still is resource heavy, so they really couldn't do any of that data collection from a mobile device. And then on the laptops that they were using, it really didn't support it either. With setting up kind of a new inventory system, we could use like an easy to use web map that they could use in their trucks, or they could even, if we built it out correctly, they could even do some of this auditing from a desktop throughout the winter. The reason why I started looking into Street View particularly was because this past summer I noticed a lot. I use Street View daily, just preface it with that. But I noticed that Lewiston itself, all of our roads started being updated with this 2025 imagery. And it was enough so that I started putting two and two together where I was like, okay, if we have all of this new Street View imagery, it's basically free to use. Everybody can use it from any device. Can we use that in tandem with this audit to get kind of the biggest bang for our buck? Our guys wouldn't have to go out and visit every pole. They could do it from a desktop. They could do it, especially with winter hitting. Like our construction season has slowed down a lot, so they had more time to focus on this. And plus, it would be if we're just pulling metadata from the Street View, it's essentially no cost. And then we can tie it to our existing GIS infrastructure pretty easily. So the first step was kind of figuring out how to create a Google API key. This was a little tricky, so I included it in the slide. I went down a few rabbit holes finding the right website for this. But once I was in the right place, the account creation was relatively simple. If you want to create your own, all you have to do is click that link right there, and it'll take you to the right place. You do have to create an account to be able to use this API key, and there is a free 90-day trial associated with that. And I think you do get a $300 credit with each new user. I don't know what you can leverage that $300 credit for because we never used it, but I don't know. I'm sure that's a perk for somebody.
I can
Um,
give some context on that, Lance, a
yeah.
little bit because I use this in teaching an R course because you can do geocoding through R using Google Maps API.
Oh, nice.
Um, so one of the things that I've noticed with these sorts of things is that you get a refresh of credits in a month, and if you start using more than that, so if you start doing really high volume things, that's when you get dinged. So that's some context.
Nice. Yeah, and that's my kind of my next thing that I have to touch on. Thank you for elaborating on that. I appreciate it. Um, if you do want to extend beyond the 90 days, what we're doing is still free, but you have to enable billing just to add, and that's just adding a company card or something like that. There was no cost associated with our metadata pools, um, w- which is the only thing we will be using this Python script for. I know there's additional costs associated with imagery polling, which is something that we're not doing currently, but we might look into moving forward. Um, so using just the metadata polls, you can build your URLs, your Street View URLs out for free. And then the API test that I included here at the bottom, if you do end up creating an API key and are wondering if it's enabled or not, you can use that link, copy and paste, and then where the API key at the end is, you just replace it with your string. Plug that into any browser, hit OK, and then if it works, then you know your API key is working. Some prerequisites before you start your automations. Like I said, you just need to set up your account and you need to set up your billing account too. We did most of our metadata polls in that free trial period, but still there wasn't any cost associated with it. So I hate when people say things are free and then they don't provide the evidence that it is free. So I decided to include this slide. It kind of gives you the cost breakdown of what does what, and you can find this all on that website as well. But what we're looking at and what we're concerned at about is that Street View metadata, and that is an unlimited free usage cap. So that's something to keep in mind. So you have your account created, you have your billing set up if you need it, and then the last step is really enabling your API. So that is essentially these three steps right here, which is again that link. So all you have to do is hit that middle button, enable API, and that'll take you to this web page here where you just hit manage, and that'll actually give you your key once you hit that manage button. I didn't include a picture of our API key because that should be relatively secure. So just something to bear in mind, something to keep to yourself. All right. So we have our key and we have our GIS. So what can we really do with it? So we have all this 2025 Street View imagery. And what I wanted to see is how extensive that Street View imagery was. Because my argument was, well, this inventory wouldn't be too difficult to complete if we could use Google Street View to do a majority of the legwork. And the argument was, well, we don't know how extensive that Street View is. So I wanted to pull all of our roads, run it through Street View, capture all the metadata for the midpoints of those road segments. And then from that, I would get a date that the road was street viewed. Um, and I'm going to switch gears here and kind of show you how to do that. Let's see, escape, and then switch screens. Okay, so we have our roads data. For the city of Lewiston, these are all segmented. I'll show you the attribute table real quick. But these are all individual segments. There's a lot of ways that you could have handled this. Like I could have broken the roads into multiple segments and then done a return on each of those points. But I wanted something quick and dirty, to basically give me, is this road segment, does it contain 2025 imagery or does it not? So what I did, so all of these are segmented out. The only thing that you have to do is, let's see, to get your midpoints was to use the feature vertices to points tool. And this is relatively simple. All you had to do was plug in your segments, you point it to where your output is, and then you just want these midpoints right here, and then hit run. And then what that'll end up giving you is just a road center point for all of those. So what we want to do is take these road center points, plug them into, use the API key, plug them into Street View, and then get a date for all of these points. To be able to do so, there were some quirks with the Python code that I wrote. All of this data has to be in WGS 1984, or it's not going to work with the automation tool that I built. Unease Ours started out, I think, in state plain, so there was a conversion that we had to do. And to do that, I just took these center points, ran it the project tool under the data management tools, and then projected it into WGS 1984, and that gave me this one right here. So after that, you're am I sharing the right screen? But yeah, you see my map all right.
I see what looks like a slide and a map that's faded as the secondary image.
Oh man, okay, sorry. I should have checked that beforehand. Let me drag this over. There we go.
Yep, you're good.
Okay, cool. Sorry about that. I'll run through that real quick. All right, so road center lines for Lewiston. Drag and move that. We have to get these roads to points. I just searched for the feature vertices to points right here. I plugged in this road segment. My output is wherever you want to throw this. And then the most important thing is the point type, which is midpoint. And then that gives you this output, which is your road center points. So that's a dot representing the midpoint of each of those road segments. And then I had to convert those to WGS 1984, which is this data set right here, which is what I use that project to tool for. All right, so now we have a bunch of points, but because they were segmented out, we have points without XY values or without lats and longs. So my next step was to just use that simple XY table to point and then generate all those lat and longs for this. And that gives me this clean data set, which has all the properties, and it needed to run it through the automation tool. So really, it's like three steps. You break your segments into midpoints, project to WGS 1984, and then you add an XY table with your lat and longs. And then what you name these lat and longs will, it's pretty important because you have to show the automation tool where it wants to pull those from. So I think I named them, they're looking for something named like point X, point Y in the tool, but you can, if you decide to use this, you can always edit those later on. And I will show you some actual code. We're not going to get too far into the actual Python code itself. Like I said, if you want it, I'll send it to you. You can play around with it. Let's go back to my slide. From current slide. So for this one, this is just a snippet of the beginning of the code. As you can see, it breaks down what it's looking for. It shows you what your output's going to be. This one creates for CSV tables that have the road segments. It shows you the date that that road segment was collected, so if it has 2025 imagery or not. And then the example up above, that command line is actually what I plug into my PowerShell and then run from there. It prompts you, the way I built it, it prompts you for that API key. A bunch of the um, digging that I did on that said to keep it out of the code itself for security reasons. So I just followed that rule of thumb. So just something to keep in mind. So what this does, it just loops through all those midpoints. It sends API metadata requests, and then it flags locations with recent imagery. So that I highlighted that radius 30 right there because anything, it will snap the point will snap to anything in Street View that is within 30 feet. So if there's a panoramic view in Street View that is within 30 feet of that point that you generated, it pulls the metadata from that closest point. So I just used a generic 30 feet because I figured that would get me close enough to anything that I needed. And based on the returns that I got, that was more than enough range. I got a lot of returns from that radius. And what this Python code will end up spitting out is four easily joinable tables. The things that you would have to edit for your use are your personal API, what you use for those lat and long fields that you generated, and then where your road names are at. which you can specify right from PowerShell using kind of the example below the command line itself. But I will show you kind of what the output of this looks like. So we have all those midpoints, we turned them into a CSV, and then let's see, Notepad. And then we get these four Excel files right here with all of our segment information. I combined these into a master CSV, so I didn't have to show you guys four individual Excel tables. But this is kind of a breakdown. Oh, one second. Well, I thought I combined them. It doesn't look like I did. All right. Well, we'll just run through them real quick. So this is probably the most important one that I use. So it had all of these road segments that we inputted or input, and then it had the date that it was captured. So it plugs it in, it pulls the metadata to see this is the date that that panoramic was actually captured. And then it just does a one if it was captured in 2025 and a zero if it wasn't. So then I actually joined this table back to our roads center line, and that gave me something along the lines of this. So everything in green here was actually captured in 2025, which is, as you can see, the majority of Lewiston. I ran the numbers on it. I think it was like 75% of our roads now had 2025 imagery. So that was a huge win for this project because then I knew, okay, if 75% of our streets had imagery done from this year, the we could build out our utility pole infrastructure relatively easily just using the imagery itself without having to do field visits for all of these. Um, so we have our roads done. Kind of our next step was building out the pole data. So this was the results of that. 75% to 80 had the new imagery. This was usable for remote data collection, and now that we knew how to pull that metadata for those points, we could create URLs kind of using the same principle. So how I wanted to use this with the CMP polls, I would have to generate a new Python code because the code I ran for the streets just told me the dates that that information was collected. It didn't actually give me a URL that I could then link or like open up from our GIS. The new Python code with the CMP for the CMP polls also creates a pano ID, and that's just the closest panoramic view to that pole, and it captures that. This was kind of an experimental idea, so I didn't know what I would need down the road, so I captured way more than I needed to. Those pan IDs we have housed now in case we ever need them, but really the important thing that we needed was those URLs. And then this adjusts for pole location as well. So it's if our pole is offset from the road, we increase that radius slightly to get us the closest panoramic view possible. The problem with this, there were some hiccups with the CMP pole application. We went from about 16, there were 1,600 road midpoints, and with the CMP poles, there was about 8,000. So this automation tool I did run, but it did take about 3 hours to run through all of these polls. And it did provide more information than what we did collect on the roads. This is kind of an overview of what we used for our CMP poll automation. The data set that CMP had given us was already in WGIS 1984, so we didn't need to do any conversion on that. It already had a Latin long that we could use. The only thing that we had to do on our end was export it to a CSV. We increased, like I said, the highlighted radius to 40 just in case the roads were off the road a little further. I had used 30 originally, but I got more no, I didn't get a response from the street view grab because they're too far away. So that's something to keep in mind, and that's something that you can mess with on your end if need be. Um, so this is a completely separate Python script than the roads one, and but it still exports just a simple CSV with your URLs for each pole. And I'll show you what that looks like. Um, so you have all of your poles. You run this little automation tool right here through PowerShell, which is pretty simple. And then it exports this right here. So this is just another simple table. I kept all of my unique IDs, which I needed to join it back to our GIS. And then the most important thing that this generated was all of these URLs for each point. So we have a pole location and then a Google Street View image of that pole. So this was done. I ran all roughly 8,000 at once, and out of that 8,000, I think I got 700 no returns, which was pretty good. Like I said, be prepared for this to take a while. It did take about 3 hours on my machine. My machine doesn't have much processing power, but it was still it was a hefty pull. So what did we do with this information? We joined it back. We threw on with all those URLs. We posted it online, and then we built this little web map for them. So what we were really looking at is so now we have all of these CMP polls that they had provided. We ran it through our system, and now each one had a street view link that we could confirm whether or not it existed, or if it had a light on it. Um, that one it was back in somebody's house. That wasn't a good example. Let me use this one. So now our guys would didn't have to visit every single pole out in the field, all 8,000 of them to confirm whether or not a light existed. And then from here, so they could view all of these. So this is where I connected with kind of our electrical superintendent and figured out what exactly he wanted to track. So we were able to build out it's kind of just a simple form that they're going to start filling out this winter. But it has whether or not it's reviewed, some of the important asset information that they were looking for, like those arcs, those double poles, if it's ADA compliant was something that we were looking for as well. So we packaged that all in here. All of our guys have access to this web map and are able to import all of that information themselves. Once they trigger this as a yes, then that CMP pole disappears off of the web map so they know they don't have to hit it again. One of the cool things that they've done with this so far, our director was really interested in finding the double polls because we wanted to send out like basically a non-compliance letter for those. So Dan was working really hard on getting all of our double polls updated. So all of these MPs that you see is every double poll in the city of Lewiston that they were able to find using this, which is pretty cool. They found like 700 out of the 7,000 or 8,000 polls that we had, so it's not a small number whatsoever. Um, and that is just about all I have to show you. So I showed you two things. There's just two Python codes we ran through. One spits out dates for roads, one generates a URL for a fixed point. You not only can use this for pole locations, you could use it for manholes, you could use it for hydrants. As long as it is a fixed point in the ground, you can use that automation tool to create a URL for it. So there is a wider application. We'll probably expand on this next year, but for now, this is all we needed it for. And then I'm going to wrap up a bit. So this in conclusion, we had a really good return on this investment. It took me about 40 hours to build both of those Python scripts, which wasn't too bad. We had a 90% success rate on those poll returns, so we were able to generate those URLs on 90% of the polls that we inputted. And then 75% of our streets had the 2025 imagery, which was great. We were definitely in a position to use that. I'm not sure how widespread the street view imagery is for the entirety of Maine, but using that tool, you could find out for your municipality or your area of interest. This was a limited investment. Like I said, didn't take me too long to build. the it will take time for them to fill out on the back end. And then one of the hiccups I had was just processing power. So if you do want to create a ton of URLs, just know it'll take some time. This is pretty software agnostic. I know a lot of people use different GIS systems. I didn't want to build something just in Esri to be able to use in Esri, so you can use this. This runs independently of anything. You just need a Python code and PowerShell to run it, and then you can join that back to any GIS you want or web map or yeah. So, kind of our next steps in this process is we're really interested in kind of pulling those static images themselves instead of just creating the URLs. And then kind of playing with the machine learning side of Esri to see if we can automate any of those updates remotely. So some of the things that the field crews are looking for, like does it have a mast arm? We're curious if we identify enough of that and feed it back in, will it just do it itself? So that's something that we're looking to explore. Hopefully next year if we can get some funding for it. And then we want to roll this out to our other assets as well, like our stormwater infrastructure, some of our water infrastructure, and then, like I said, our manholes or some of our other sewer infrastructure as well. And that is all I have. I hope that was helpful. It was a really fun project, and I had some good input from our not only our electrical team but our GIS team as well. Um, yeah,
All right, thank you, Lance.
yeah.
So I'll open the floor to questions. Please pop them down in our Q&A feature. I'm going to start with a basic question I have. Have you considered putting your Python script and that stuff into a Jupyter notebook?
No, I've used Jupyter Notebook a few times. I use Idle mostly just out of, I don't know, it's what I learned on, so I just use Idle to do most of my coding. But I'm not really familiar with Jupyter too much.
Yeah,
Is there a
it's gonna be
way to,
relatively the same, right?
yeah.
It's gonna have it's the same language. It allows you to interface images and text and all of that. So like to give other people walkthroughs
Hmm.
of it. So like if you wanted to share the types of things you were doing and get people more connected to what it is, that might be a helpful way to disseminate
Oh yeah,
something to think
absolutely.
about.
Yeah, no, I'm used to just throwing all my comments in a Python code and then throwing it at somebody to decipher,
Yeah.
which
Yeah,
is kind of
I do that all the
brutal.
time
Yeah.
when I'm teaching courses in Python. So just something I thought of that might be worthwhile.
Yeah,
Um,
no, I appreciate that. Thank you.
and then Steve has a question in the chat. Missed the significance of a double poll that were about 10% of your totals. Is that an old poll that needs to be removed next to a new poll or something else?
Yeah, so double poles are like they're kind of a huge issue statewide. I hear our electric guys complain about them all the time, but what it's a new pole that they had started transferring all those services over to, and then usually you have like a telecom left on one pole that hasn't been transferred, so then it can't be removed. So you have two poles taking up space where one pole would do. And there wasn't really, we weren't tracking that, and it's been a big push for municipalities to kind of provide examples as to why that is an issue. So I hope that clears that up.
Are there any other questions for Lance? So I saw you mentioned you're interested in doing this with some machine learning applications, right?
Hmm.
Um, is there any would there be any impact if it were to get that wrong and you just blindly accepted it? Because one of the things that we always worry about with machine learning and AI applications is when they make a mistake and they don't get scrutinized.
Yeah, I think we would use it on data that really it would be nice to have, but it isn't extremely critical. Like any of that critical data identification, I think we would do in-house. So like if it misidentifies as something as a mast arm, for example, it's not really a massive deal as compared to the general lack of information that we have in our system right now.
Okay.
Yeah. But no, totally agree. I don't think we'd want to point this at critical infrastructure and then have it make decisions based on that.
All right. We have a question in the chat from Robert. How does CMP locate their poles?
CMP, so I did an inventory for CMP in 2022. This was on the ground. I worked with a field staff of 20. They subcontracted out Davy Tree Company to actually go out and field or site visit every single pole in Maine. So they had a complete inventory of Maine done in 2022. The accuracy of that data is hit or miss. Sorry. Um, but depending on who's collecting the information, right? So, uh, yeah, it was a pretty robust program. They did field visits for all of it, but as you can see, 3 years later, they didn't collect the information that they needed. Um, so it's just another tool. Sorry,
All right.
I have a
So,
visitor.
yeah, go ahead.
Oh no, I had a visitor. Sorry.
Oh, yeah. So next question, is it possible to get access to the code that you used for the people who are here at the presentation?
Yeah, like I said, in the beginning, I'll email it to you.
All right. So that will go along with the we send out a link to the people who registered with all that. So we'll put a link to that as well.
Yeah, I'll do some fine tuning of it. Yeah, some of my comments. Yeah, I'll make sure it's a little more user friendly before I send it out.
All right. Next question. Does the city of Lewiston use a street lighting software with lighting schedules, or is it largely PhotoCell, PhotoEye?
I'm assuming it's PhotoCell. So they don't use any software to control any of that. I think it's just based on if it's dark or not, it kicks on. So that's where like that back end calculation is important. So they're just looking at light tables for the year. This day we had this much light. We're going to charge this much for that day. It would be nice if we had software. That would be a move in the right direction, but we're not there yet.
All right. Do you have any other questions for Lance? I'm seeing that we have no open questions. So just as a reminder, first off, thank you, Lance, for the presentation. Glad to have folks from the outside of the executive board doing some of this, and I hope that there are people here who have things that can to contribute and would love to be involved with this. If you'd like to do that, please get in touch with me. I'm pretty easy to find. And I also would like to remind folks that we have our next Lunch and Learn on January 14th. It'll be about the crosswalk between SQL and the GIS. So for those, this actually kind of relates in some way to what Lance is talking about in a sense, because we're looking at computer code to deal with problems in data sets and whatnot. So they go hand in hand, though it's a vastly different type of application. I won't treat it from an application standpoint. Um, so, um, so I look forward to seeing some folks there. Again, if you have interest in giving one of these talks in a future month, we do these once monthly. So please let us know. And with that, I think that's a wrap.
Yeah, thanks everybody. Thanks for bearing with me. I don't do presentations too often, but if you have any questions, feel free to reach out.